Hi everyone, my name is Maggie and I'm going to be giving a presentation today on a mapping demonstration. This is me. So step one, we're going to organize the given data set. Over here on the right, you can see the given set of data. We're going to isolate the non-crossover, double crossover, and single crossover from this group. The non-crossover is going to be our two highest numbers, which is here at the top. Our double crossover is going to be the two lowest numbers, which we can just kind of look at from here. And our single crossovers are going to be what's left. And the single crossovers are also going to be organized by highest and lowest remaining numbers. This is our data getting all organized. So over here, we have our non-crossover, as we just said, is the highest numbers that we have here. We have a total of 2,702 for our non-crossover. Our double crossover, two lowest numbers. We have a total of 240. And here are our single crossovers, the two sets of data that were left. So here they are organized by lower and higher numbers. We have our first one to be a total of 820, the second one for a total of 1980. Here is the data again for reference, and we also have a total here at the bottom, which we're going to use later, of all of the given data set. Step two, we're going to determine the correct gene arrangement. So I have three possibilities laid out here. And what we're doing is we're looking to match the double crossover, which is here, A++. So let's look at the first one. We have isolated plus B+. That's not what we're looking for. So we're going to move on to possibility number two, where we have plus C+. Also not what we're looking for. We're going to move on to possibility number three, which we have plus A+, and that is what we're looking for. Two pluses and an A. Now we have to organize all of the genes with the correct arrangement that we just found of A++. So each set of data, we're going to make sure that an A is in the first spot, and then there are two pluses in the next spot. So it doesn't change the totals of the data here, but it just puts them in the correct order that we just found. So again, A++, A++, and A++. Step three, determining the distance between the genes. We're going to start off with our non-crossover here. And we have the total of 2,702 as we decided before by adding these numbers. That number gets plugged in here. This 5,742 is the total of the given data set that we had talked about on the previous slide to get a decimal of 0.47. But we want to view that as a percent. So we're going to multiply it by 100 to get 47%. We're going to repeat that process for both of the single crossovers and the double crossover to get percentages of 47%, 4.2%, 34.5%, and 14.3%. Now, determining the distance between the genes. To get this number up here of the number of map units, we are going to add the higher of the single crossover plus the double crossover to get 38.7 map units. For the distance between A to C, we are going to have 14.3 plus 4.2, which is our lower single crossover, plus our double crossover to get us 18.5, which again, we plug over here to 18.5 map units. Step four, we're going to calculate the coefficient of coincidence. We just found the map units, but we want to put that back in a decimal so it's easier for us to work with. So divided by 100 on both sides to get our decimals. The double crossover is, our expected double crossover is those numbers we have above, 0.387 times 0.185 to get 0.0716. We're going to turn that back into a decimal so it's nicer to look at. And our coefficient of coincidence is the observed double crossover divided by the expected double crossover. So we're going to plug those numbers in here to get 0.042 divided by 0.0716. To find our coefficient of coincidence is 0.587. Our fifth and final step here, calculate the interference. We're always going to start with 1 minus the coefficient of coincidence. So we have 1 minus 0.587 to get 0.413. But again, we like things in percentages because it's easier to look at. So multiply by 100 to get 41.3%. And now we can conclude that the positive interference of 41.3% less DCO occurred than we expected. That's my presentation on mapping. Let me know if you have any comments or questions